Welcome back to the Sparkfun Inventors Kit for LabVIEW tutorial series. I'm Sam Christoph from LabVIEW MakerHub, and in this section, we'll learn how to manually control 4 LEDs, and then we'll update our code to display the binary representation of a number on those 4 LEDs. I've connected 4 digital channels to the anode side of 4 LEDs, and then connected the cathode side to ground through a 330 ohm resistor. There's a link below to the circuit schematic, so make sure to check that out. From the LabVIEW Getting Started window, I'll click Help and choose Find Examples. This will bring up the example finder, and then I'll click Search and type links. Then I'll click the Search button, and we're going to start with the links digital write N channel example. So this allows us to write multiple digital channels in one function. So I'll double click that to open it. This brings up a standard links example. So we need to select the serial port for our breadboard. In this case, I'm still using COM3. And then we specify the digital channels to write to. So in my circuit, I've connected pins 10, 11, 12, and 13 to LEDs. And I know that the top LED is connected to pin 13. So I'll start with pin 13 on the top, and then 12, 11, and 10. Now I'll click the Run button to run the code. And it'll take just a second for LabVIEW to establish a connection with the breadboard. And when it does, I can click on the LED controls, and you'll notice as I do, the LEDs on my breadboard light up. If I click them again, I can turn all of the LEDs off. So let's take a look at the code. I'll press the Stop button to stop the VI, and then press Control E to open the block diagram. You can see, just like most of the other links examples, we establish a connection to the links device. Then inside a while loop, we use the digital write N channel VI. And we pass it an array of U8s that are the channels. So that's our 13, 12, 11, 10. And then a Boolean array that represents the values. And if I double click that, we can see that that's the Boolean array control on our front panel. At the end, we close the connection using the links close VI and use a simple error handler to report any errors. So let's modify this code to display the binary representation of a number. I'll add some space in our while loop, and you can do that by holding Control and then left clicking and dragging, and it will add white space. Then we'll add a numeric control. So I'll jump to the front panel by pressing Control E, and I'll right click to bring up the controls palette and choose numeric and control. And I'll place that on my front panel, and I'll call it value. Then I'll double click on that to find it on the block diagram. And we can see that by default it's a double. And we want to represent this with our 4 LEDs, so basically 4 bits. There isn't a 4-bit number type in LabVIEW, but we can use an 8-bit number and just ignore the upper 4 bits. So I'll right click on the control and choose representation, and then choose U8 for unsigned 8. We need to get the individual bits of this number. So there's a function in LabVIEW, and I'll use quick drop to find it, called number to Boolean array. So quick drop, I search for number to Boolean, and you can see the number to Boolean array primitive. So I'll left click to place that, and you can see if I hover close enough to that control, it'll automatically create that wire for me, and that's where we want it. So I'll let it do that. Then I'll take the output, which is a Boolean array, and we're going to replace the manual LED array control that we're using. So I'll go ahead and delete that, and then I'll connect my wire, and I'll hit Control B to remove the wire fragments. So now we're taking a U8 value, converting it to a Boolean array, and wiring it into our digital write N channel. Now, we've only selected 4 values for our digital channels, but we're passing it 8 bits because we're using a U8 numeric. And this doesn't matter. The 4 uppermost bits will be ignored. Let's switch to the front panel and click Run to run the VI. And our default value here is 0. So once it starts running, which we can see the RX and TX lights are on solid, so it is running, we'd expect a 0 output. And I'll click in the value control and then use the up arrow to slowly increment. And you can see as I do, the value is displayed in binary on our 4 LEDs. Now, when I get to the maximum value that we can represent on 4 LEDs, which is 15, you can see they're all on. And if I increment this again, you can see they're all off. If we had a fifth LED, that would turn on now, but since we don't, we just see the lower 4 bits. And now I can keep counting above that to see the 4 lowest bits. So that does it for controlling multiple LEDs. Make sure to join us next time when we talk about controlling LED brightness. Until then, think about how you could modify the software to include a counter start value and maybe a maximum count. Or how could you modify the circuit to show all 8 bits of the count value? Make sure to check out LabViewMakerHub.com for more tutorials and projects, and ask any questions you have on the MakerHub forums at LabViewMakerHub.com/forums.